All right, fractions. We have an addition problem, a subtraction problem, multiplication, and division. And really, addition and subtraction are the trickiest, right? Because you have to get a common denominator. For number 1, we have 3, 9, and 5 as our denominators. So I like to look at the two bigger numbers. What do 9 and 5 both go into? Well, 45. 9 doesn't go into any of the other multiples of 5. So my common denominator is going to be 45. So I'm going to need to multiply my 3 fraction by 15. And whatever I do to the bottom, I have to do to the top. I'm going to multiply my fraction with the 9 in the denominator by 5 over 5. And I'm going to multiply my fraction with the 5 in the denominator by 9 over 9. So here's how that looks. 15 times 2 is 30. 5 times 8 is 40. And 9 times 4 is 36. Now that I have that common denominator, I can just add my numerators. 70 plus 36 is 106. Again, for subtraction, we're also going to need a common denominator. 4 and 6 both go into 12, so we're not going to have to do quite as much multiplying here. So I do like, though, to write down that denominator that I'm going to be using. It kind of helps focus me in. Makes me feel like part of my problem is done. So to get that 12 in the denominator, I'm going to multiply by 3 over 3. And for my 6 fraction, I'm going to multiply by 2 over 2. Now, if you don't, like if you were thinking, oh, I'm just going to use 24, because 4 and 6 do both go into 24, you're just going to have to reduce at the end. If you don't find that least common denominator, that's okay. Just look for that reducing. So here, 3 times 3 is 9. 5 times 2 is 10. 9 minus 10 is negative 1. The biggest issue I see with multiplying fractions is just sometimes I have students who want to find a common denominator and it way overcomplicates the problem. So when you're multiplying with fractions, you just multiply across. Go, 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 do it. So 5 times 10 is 50. 6 times 9 is 54. And then reduce. So I can reduce 50, I can take 2 out of both. 50 divided by 2 is 25. 54 divided by 2 is 27. The other thing you could look for there is anything that you can reduce, so within the problem before you multiply. So if you looked at my work on that I posted, I did this. Well, 10 and 6, I can take a 2 from both of them. And then 3 times 9 gives you 27, and 5 times 5 gives you 25. So I'm basically reducing my fraction first before I multiply. That order doesn't matter, so you can absolutely do that. Dividing fractions, you need to flip the second and multiply. Here is your second. So this is a multiplication problem. It becomes a multiplication problem, and then you can roll. I'm going to show you that simplifying again here before we multiply because I do think it is helpful. 8 and 6, I can take a 2 out of both. So I'm going to divide 8 by 2 and get 4. And divide 6 by 2 and get 3. And now my numbers are smaller for multiplying. I do think that if you can recognize that, especially when you're working without a calculator, that's helpful. So 12 times 3 is 27. Oh my goodness, not 27, sorry about that, 36. Over 4. And I guess we could have done even more there. We could have done that 12 divided by 4. 36 divided by 4 is 9. Again, you could have done this division once you knocked that 3 and 4 down to 3 and 4, and you could have gotten to 9 even faster. Lots of options with these. Just make sure you know what you're doing. All right, that's for